All right, this is what we have done. And now I'm going to do a different type of code so that we can look at recursion again. All right, so I'm going to do recursive subdivision, or what I call as ice ray. It's kind of ice ray subdivision, something like this. So we start with a rectangle and we divide it into irregular polygons. So it's something like this. There's already a diagram. This is great. So imagine us having a polygon. Let's call this Q, defined by 4 vertices, A, B, C, D. Okay. We are going to find 2 points, one between A and B, and one between C and D. So between A and B, we have E. Between C and D, we have F. And we are going to define 2 new polygons using these 2 new vertices. So one polygon is going to be AEFD, Q1. The other one is going to be EBCF, Q2. All right, and this is basically the rule. So take a polygon and segment it along 2 edges. So we're going to do this recursively and see what kind of subdivisions we can come up with and change the parameters as well. Okay. Any questions about this rule? It's pretty clear, no? So let's take a rectangle and split it and along 2 edges, basically split the operation, but we have to do this in code now. All right, so I'm going to start a new sketch. So the first things first is we need to define what a rectangle is. So how do we draw a rectangle, basically? So there are multiple ways we can do this. Maybe we can also introduce you to classes. But shall we do it? How shall we do this? Shall we do it as a class-based, actually? I'm thinking we should probably do it as a class-based. No? Shall we do an object-oriented way? You want to see objects, classes? I'm thinking if it could be done in a more simpler way. So imagine us starting with a rectangle, splitting into 2. We can find these points, but then we have to send the function again. Well, it's going to have a lot of points, probably. Let's do it without the classes, and then I'll show you. We will revisit this in a class-based way, okay? So let's call a function to draw the rectangle. So I'm going to use vertices now, and we can do create vectors probably. Let's do it vector-based. There are a lot of things we could do, actually. This is fun. This is going to be fun. So let's define the first rectangle. How do we draw rectangles? So let's define 4 points. Let A equals create vector. So let's define it at a value. Let's call it offset value. That offset. Are you guys there? Are you watching? I'm not hearing anybody say anything. I started already.
Here.
Okay, cool. So offset, that will be our first point. Let B equals create vector. B is going to be at the lower end, so we're going to do it offset height minus offset. Let's call this off so that it will be easier to write it off. All right, let's see equals create vector width minus off, height minus off, and let D equals create vector x is width minus off and y is off. Does everybody understand these locations now? Okay, and I'm going to define a function called show rect or we could do it show poly A, B, C, D. Now we're working with functions.
Of meaning random or just give a 0.0?
No, I'm creating an offset, so I'm going to create it as a frame inside of the canvas.
Okay.
Okay, that's why I defined it as an off parameter. We could also we can create off to be 0 as well. So show poly, what is show poly? I want to create a new function. Call it show poly. This will basically visualize a polygon. So call it V1, V2, V3, V4. Those are our vertices. So I do begin shape and vertex v1.x, v1.y, right? Do this 4 times and shape close. We could do stroke 0 and fill 255, 0, 0. This will be V2, this will be V3, this will be V4. All right, background, let's move it here. That's our first polygon. Voila. All right. Now what do I want to do? I want to take 4 values, which are basically 4 corner points. I want to find, so this is, where is A? A is here, B is here, C is here, D is here, right? So this is going counterclockwise. So I want to find a point between A and B. I can also change the ordering, by the way. We can start at the bottom right, but it's okay. Let's keep it this way. I want to create a point between A and B. Let's say here. And another point between C and D here. And let's call this E or AB. Let's call it AB actually. AB. And this is CD. And I want to draw 2 new rectangles in between these two. Okay? And define these as clockwise as well. Maybe the other one will go this way. We will see. Does this make sense? That's the algorithm. And we're going to do it recursively. You guys want me to like teach for 3 hours nonstop? I cannot talk for 3 hours.
I mean,
yeah, I mean it's just yeah, you want to just torture me, like listen, when I ask you like if this is okay, like you want to keep continuing, but like I can continue so far as my throat can handle. It's just funny. I mean yeah. Let's see if I can continue. Guys have no care for your instructors. Okay. So show poly. Well, rather than doing show poly now, what I can do is, well, this is a rectangle right now, right? So I can maybe use this as a function to divide a rectangle and give me 2 new rectangles. So what I want to do is define this probably as an array and have the output to be given as arrays as well. So how do we define arrays in JavaScript? Did we do that as an example? Let's see. Arrays in JavaScript. Let's go here. Yeah, we need to use these brackets actually. All right, so item 1, item 2, item 3 separated by commas. So that could be just one list. All right, so let's do divide. So what I want to do is subdivide, define a new define a new function, and then inside of it, I want to pass in an array with A, B, C, D. Okay. Now I have function subdivide, and call it points. So points is going to be a list of points, right? A, B, C, D. Now I want to find a point in between A and B and C and D, right? That's what I want to do. Okay. So inside of this, we could do it like this. A is going to be 0.0. B is going to be 0.1. C is going to be 0.2. D is going to be 0.3. Okay. And I want to do AB equals, let's call it a function. So I want to interpolate between A and B, right? How do we do that? So let's call it interp. Well, we could also do create vector a dot x plus b dot x minus a dot x times what amount? 0.5. Let's call it 0.7, comma. So I'm moving from A to B 70%. Let's call this as a parameter, actually. So let's create a parameter, call it 0.7, and call it par. And this is par. And we will do the same thing for its y location. So I want to move from A to B by a certain amount, right? So AB will be between A and B by a percentage. And that's the equation for it, right? So we're interpolating between A and B. So I'm adding to A's location a vector, which is defined by the difference of the x and y values. Same thing for CD. So I can copy this and replace A with C and B with D. So I have now two rectangles, AB and CD. Right, so how would this work? So when I call subdivide, I will basically create a point between A and B. A is here, B is here, C is here, D is here. Right. I got my sore throat 8. Relief of sore throat. Let's pick one. All right, so I have AB, CD. AB is going to be 70% along AB. Right, so it's going to be somewhere here. And same thing for CD. CD is going to be somewhere here. So let's see if they are at those locations. Circle AB.x, AB.y, 5. And let's see if, yeah, same for CD. There we go. Let's do fill 0. Let's make this 25. So that's AB, that's CD. We are subdividing now, edges. Right? So I want this function to return two new rectangles now. So remember that we had A, B, C, D. Now I have new midpoints. So I want to get two new rectangles. So what are those two new rectangles? Well, we could start with A, but what I want to do is start with AB. So I start from here, going this way. And I also want to start from CD and go in this way. There's a reason why I'm doing this clockwise and counterclockwise, so that the subsequent division operations would actually divide them like this, right? So I want to get some sort of an offset for the division. Make sense? So how do we define this? We start with AB, go to CD, D, and A. That will be one rectangle. So let's write that. So one rectangle is going to be AB, CD, D, and A. The other rectangle is going to be CD, AB, BC, right? Those are two new rectangles. Well, I could have defined these as objects, but I'm defining them as arrays now. So rect1 equals this, rect2 equals this. So are you noticing something? Are you noticing something? So we have a function called showPoly, and we have a function called subdivide. Now, technically speaking, this function could be recursive, right? Because what it does is it takes 4 corner points and it subdivides them. And I want this to keep subdividing itself until some threshold is met. So that threshold could be generation, basically. So let's define it as let gen equals 5. Or let's start with 2, right? So I want to feed this in here. So I want to subdivide this rectangle, my initial rectangle, at 0.7 by the amount of gen. So when I call this function, remember, we can have recursion, right? So this function can call itself back again. Inside of this, I can check for gen. Let's call it G here. So if G is greater than 2, I want to keep segmenting the rectangle. So I want to do this. If G is greater than gen, oh, we will pass in 0. If G is, let's call it less than gen. Oh, my throat is done. Ah, I cannot speak. You just watch me code it, and I'll just write comments on the script. My throat is killing me. Okay. Oh man, it's gonna be a long day. Sorry, guys. But I cannot teach. I cannot constantly speak for 3 hours. It's impossible for me. So yeah, you should turn on your screens and let the talking a bit rather than have me talk all the time. All right. So let's do G smaller than gen. Okay. So we do just greater than 2, 0. Okay. So we want to call this again. Subdivide. Rect 1 par G plus 1. So it's going to call this again, divide it into a new rectangle until this condition is not met. And when it's not met, we want to show the poly. Show poly. A, B, C, D. No, we want to do, well, it will still calculate subdivision though. Maybe we should do this. We could also change it to be like this. And call this points. 0. I'm changing this into a list. So it's going to segment until it can't. And then when it can't, it's just going to show me the rectangle. There we go. That's the rectangle. This guy. So in the second generation, it segmented it here. The first segmentation happened here. Second segmentation happened here. And this is the third segmentation. Now we can do this for the other side as well. So I can do subdivide rect 2 par G plus 1. Row poly rect 2. Did this work? Let's comment these out. So that's the first subdivision. Something's not working though. The other part is not working. So we do subdivide. We get 2 new rectangles. And we send them back to the subdivision. So why doesn't this come in? We do G plus 1. We start with 0. This should work. Gen is 2. Start with 0. That's correct. Rect 2. Is this incorrect? Why can't we see this? Let's make this into 1. So I should only see 2, no? I call this back points. Par is 7.7, 0.7. We actually let par equals 0.7. That would be the percentage. We don't need to input this anymore here. We can delete this. And we can use it there. What does it say? Maximum call stack. What? All right. Rec2. Why can't it define rec2 for some reason? This is interesting. CD. We changed this to CY, DY. What's wrong? A, B, C, D, A, B, B, and C. Oh. What is this? CD? I'm inputting the points wrong, I guess. So A, B, C, D. This is A, B. This is C, D, right? So we do A, B, C, D, D, and A. And then we do C, D, A, B, B, and C. That is correct. That seems correct to me. This is correct. Show poly points. That's also correct. This is weird. Let's comment these out and see. All right, so that's one. Is it because G is incremented by +1? G equals G plus 1? And let's submit G. Maybe that's the issue. No? This is 0. If 0 is less than gen, which is 1. So maybe I'm missing something. We keep subdividing. And then when we can't, we just visualize the polygons. Okay, and the polygons are here. That's correct as well. C to D. Did I write something wrong? Maybe this is not
Ya
right.
kaygını YouTube'a ne zaman yüklersiniz acaba?
Efendim?
Ders kaygını ne zaman yüklersiniz kanalınıza?
Tekrar çekeceğim herhalde. Ne
Ya
zaman
çok
vaktim olur bilmiyorum. Bu hafta sonu olabilir.
bu seferki konu birazcık zorladı da birazcık çok yer kaçırdığım yerler oldu. En azından ders kaygını tekrar izleyip öğrenme şeyim daha iyi olabilir benim için.
Olur. Bir daha çekeyim. This works fine. We show the polygon. Okay. If I do it this way. Somehow this doesn't register. And when we start with 0. Show poly. There isn't an issue here. These are points. Okay. What am I missing here? It's always going on one side. So these are two new rectangles, generating 2. If it cannot segment then it should visualize it probably. Okay, so this should just do this. So I guess like this. And then points. Doesn't make sense, but no, this is incorrect. So this works when we get two rectangles, when we do subdivide. Why didn't this work? I'm kind of stuck here, so funny. Subdivide. Okay, so subdivide this rectangle. We get two new rectangles. Oh, but we should do it this way probably. So when we get a rectangle, we should do the G before. So if G is smaller than or equal to gen, then we should segment it. Else, we should just visualize it. Yeah, that will affect the algorithm, I think. So we should only show it, show poly points, or we should just segment it. So if G is less than gen, we should define two new rectangles. And then we should send it back to subdivision, both of them. Yeah, I guess this is the correct way. If not, if it doesn't segment, we just show it. Right? What's wrong? What am I missing? A, B, C, D, D, A, C, D, A, B, B, C. That seems correct to me. Is this the problem, G, gen? Zero. When it's 1, 1, okay. So these entered here when it's 1. I guess this fill is kind of hiding it. I guess I figured it out. So this fill is the problem. So no fill. Because it's overriding to the shape. Is it? Shape equals stroke. So one side is subdivided. What about the other side? Is this the issue? Can we do vector interpolate? Let's do vector operations, create vector. Let's create the vector. Methods, add, copy, subtracts XYZ components from a vector. Division, normalize distance, heading, set heading, rotate angle between. Lerp, linear interpolate the vector to another vector. I guess this would work. P5 vector dot lerp. Yeah, let's use this. I don't think this is the issue, but let's try doing this. So this is A, this is B. From A to B by par. And this would be from C to D by par. Okay, that's exactly the same thing. Rectangle 1, A, B, C, D, D, A. We also have closes here. That's fine. X and Y's, that's fine. Begin shape. Am I missing something here? Rect 1, G plus 1. Rect 1 doesn't go here.
Tam dersiniz başlayacaktık ya başka bir.
Okay, you can go. I want to figure this out before I leave, but I'm gonna give it 5 more minutes. This is done. I mean, I'm just missing something here. That is maybe one of these words, or oh, I see what it is. I see what it is. I didn't declare these as variables. Oh boy, it's done. All right, there's. So I didn't declare these as variables. It's my mistake, but basically, it's not defining this as a variable and overriding it every time. So I wasn't able to store them in the memory. But now this is working. So I can now, if I do it, gen is, let's say 10. Voila. So that's basically 10 generations of recursive subdivision. This is 5 generations. And we could also do, if I change this parameter to be 8.
And we say every different rectangles,
Can
different
we
size.
make it, you want to make it every different rectangle a different color?
Different size. I mean, not 10.
No, we cannot make it into a different size because it's subdividing
Or
it. Remember the algorithm?
random.
So we have a rectangle and we are segmenting it. That's how the algorithm works.
Yes.
I start with a frame and I segment the frame, and then I keep segmenting the frames, and then I keep segmenting.
So each figure always the same. Right?
Yes.
Hepsi mesela 10 hepsi 10'a bölünecek.
Evet.
Onu değiştiremeyiz değil mi? Bağcıları 8, bağcıları 5 yapamayız.
No, we can.
Right.
We can just do, like, we can increment them at different intervals. So if I make this G plus 2, then some of them will divide more.
Okay.
It's asymmetrical basically, right? So yeah. Or we can make the rate of division to be, yeah, like this, for instance. And then show polyfill, do the random 255 0 0. So it will be a random red, right? Cool. Cool. Okay. And if I do 8, that's how it looks like. If I do 1, that's how it looks like. So remember, this is always evaluating a location along those edges. So it's kind of a percentage. If I do 0.5, that will be midpoint. So it will be a grid. Make sense? So it takes in a rectangle, initial rectangle, and it subdivides it using this parameter. And we find 2 new points between A and B. So let me go back to the older version. This should work as well. And define 2 new rectangles at the divisions. So if I do it 1 generation, this is what we'll do. If I do 2, 3, 4, 5, 6. This is deterministic, so it will keep segmenting those. 8, 9, 10. Let's do 30. It will take a while to calculate because it's recursive is subdividing it now. Oh, it's taking too long. It crashed.